Hi, welcome to Number Club. This is Year 1 Pure, Chapter 2, Lesson 6, and today we're going to be using some quadratics for mathematical modelling. This is just one exam question. They quite often follow the same sort of pattern, so we'll get cracking. What I've done is I've put the exam question over 2 slides. So let's see what we've got. A stone is thrown from the top of a cliff. The height h in metres of the stone above ground level after t seconds. So this will be some function relating height and time is modelled by, well, height in terms of time. So what we'll have is going to be somebody stood up here throwing the stone, okay, until it hits the ground. Now this height is going to be important. That happens when time equals 0. Okay, this is time and this is height relative to time. And so we've got the first question, which says give a physical interpretation of the meaning of the constant term 115 in the model. Well, that 115 is here. H of t equals 115 if t equals 0. So when the time is equal to 0, nothing's happening. It's your initial time. It's just as the stone is being thrown. Okay. Now, some people might call it the height of the cliff. Some people might call it the height of the cliff plus a person. For me, I just say that it is the height from which the stone is thrown. Okay, that'll do. You don't need to be too fancy with it. That's just where it is. So it might be that the cliff was here and then you've got a person stood there. It doesn't really matter, but really call it the height from which the stone is thrown. So it's just as the stone is being released from the person's hand. So write h of t in this form. Now this form here is a bit of a strange looking one, but it is the completed square form. So we're going to need to try to complete the square on this thing here. Now the reason they're asking you to complete the square is because completing the square can give you the solution, give you the root when does it hit the ground, which is going to be included later. It can also give you the maximum, okay, and the time after which the maximum happened. So let's have a look at completing the square for this thing. So the first thing is to rewrite it in the correct order, the one that we tend to like things to be. So we've got negative 4.9 t squared plus 12.25 t plus 115. Now I might well get quite a few fractions and things like that within this question, and I'll be mixing fractions and decimals a little bit because the decimals probably come out as quite annoying ones. So the first thing to do is to divide out that 4.9. So we get 12.25 divided by 4.9, which is going to be 5 over 2. So we divide out the 4.9 from the first two terms. So divide out negative 4.9 and you'll have lots of t squared plus 5 over 2 t and then plus 115. And imagine we were to expand this back in, we'd end up with negative 4.9 t squared and we'd end up with, minus there. Okay, we'd end up with positive 12.25, and you should always double check. You see, I just made a mistake. You should always double check, okay, especially with the signs. So now we're going to complete the square within those big square brackets. So we'll have t minus 5 over 4 all squared minus 25 over 16 plus 115. Okay. And then we're going to multiply in by the negative 4.9. So we'll get negative 4.9 lots of t minus 5 over 4 all squared. Negative 4.9 multiplied by 25 over 16. I'm not going to try and do that one in my head. We've got 25 over 16. It's going to be 245 over 32. Okay, so we get plus 245 over 32 plus 115. And don't break your back doing all these fraction calculations. Just let your calculator take care of that for you. So we get there, and we're going to add on 115, which comes out as 3925 over 32. Okay. So we need to get this in terms of A, B, and C. So we've got this thing here is in a different order from what we've got. So h of t will equal 3925 over 32 minus 4.9, pardon me, lots of t minus 5 over 4 all squared. And so A equals 3925 over 32. B is equal to 4.9, and C was equal to 5 over 4. It's okay to have a mix of decimals and fractions if it's just easier. That's fine. I could, if I wanted to, convert that to 49 over 10, but I don't really think that pays off. Okay, so we're going to be using that to develop some solutions. So let's move on. Okay, so using your answer to part B, which was this thing up here, or otherwise find with justification, the time taken after the stone is thrown for it to reach ground level. Now, if you think we've got the stone being thrown, when is it going to reach ground level? It's one of the solutions, isn't it? It's when does h of t equal 0? This here was h of t. When will it equal to 0? So we're going to let this thing equal to 0. So we'll have, we've got 0 is equal to 3925 over 32 minus 4.9 lots of t minus 5 over 2 all squared. We're going to move this over, so we'll get a negative 3925 over 32, cancel off the negatives, so we're going to get 3925 over 32 is equal to 4.9 lots of t minus 5 over 2 all squared. We're going to divide by 4.9, so we'll divide by 4.9, which is going to equal 19625 over 784, so we get 19625 over 784. Don't expect nice numbers from here out. T minus 5 over 2 all squared. We're going to root and then add on 5 over 2. So we're going to have 5 over 2 plus or minus the square root of 19625 over 784 would equal t. Okay, so we rooted and then we added on 5 over 2. So that would be the value once we work it out for t. Now, if you imagine this quadratic up here, it would have this other side. Now, obviously, t cannot be negative. Okay, we should work out both though, and then we should figure out, whether we've got the positive or the negative version. Okay, so let's have a look at what those come out as. Okay, so we had the plus version that came out as 7.50 and the minus version that came out as negative 2.50. Okay, we can't use this. So what we'll do is we have to consider both, but we have to say that choose t is equal to 7.50 as t is greater than 0. Okay, the time has got to be greater than 0. We can't have a time traveling stone. All right, moving on. We had find the maximum height of the stone above the ground and the time after which this is achieved. Now, it will be the turning point. So take a look at what we've got up here. We've got h of t is equal to negative 4.9 lots of t minus 2.5 all squared plus 3925 over 32. So my turning point is equal to 2.5, that bit there, and positive, we don't really need that, 3925 over 32. So maximum height of 3925 over 32, it would make sense to give that as a decimal, so we've got 3925 divided by 32, which comes out as 122.66. 122.66. Was it meters? Yeah, meters. Okay, meters is reached after 2.5 seconds. Okay, so that's when the stone goes up. After 2.5 seconds, it starts to decrease. Okay, it starts to decline. So eventually, it hits the ground after 7.5 seconds ish. All right, that's an example of one of these questions. As you can see, though, the most important thing is that you're really, really, really good with completing the square. Rely on your calculator quite heavily, but you do need to be able to complete the square really effectively to deal with this. All right, thanks very much for watching. Visit numberclub.org to find some more videos and tasks. Thanks.